Okay, students, we're going to take another look at section 9.4 here, and I want you to follow along on this note sheet here, which is this Word document you should have in front of you. So follow along as we go through this lecture here. First of all, I want you to explain how you would multiply two fractional expressions like this. This one's multiplied, this one's divided. Write out in numbered steps on your note sheet how you would do this after you copy them from the board here. So copy them here, and then write your numbered steps here while talking to your neighbor. Okay, take a minute to do that, and we'll come back in a second. Okay, hope you're done with that, and I hope that you wrote down something about canceling or cross-canceling here with these expressions, because you certainly can cancel the 2 into the 12 and put a 6 here. You can cancel the 5 into the 10 and put a 2 there. And now that you've got this 2 and the 6, you can cancel the 2 and the 6 and reduce it to 1/3. That's the easiest way, I think, to reduce that whole fraction there. With division, the one thing I hope you remember is that you have to flip this other one and multiply it. So you'd get 21/8. Hope you remember that. I take the reciprocal of this. Dividing by that fraction is the same as multiplying by its reciprocal. Then you see some easy canceling there. 4 goes into 8 2 times. 7 goes into 21 3 times. So my final answer would be what's left over here. 3 divided by 2, or 3/2 should be your answer there. I hope that is very clear to you from previous classes. Okay, what about these fractions here? Would this be the same rules or different rules here? Well, we hope you see that it would be the same rules, but it's a lot more complicated, but still you would know how to do this. First thing I can do in this one is I can cancel some numbers here. I can cancel my coefficients, change that to a 2, right? Divide that by 2 and I get a 1. There's a 1 left over here. Divide this by 2 and get a 2. Now I can look at my exponents here. Okay, can I cancel anything x and y? Well, I could, but let's just simplify it first. I get 3/2 for my coefficients. X squared times x third. I add those, so I'm going to get x to the 5th. The y is left over. That's really y to the 1st. The only thing on the bottom here with variables is y squared. So what can I do now, right? I can cancel this y and this y squared and that y. If this is y to the 1st divided by y to the 2nd, it's going to leave me with a y to the 1st in the bottom, right? So I'm going to get 3/2 x to the 5th over y would be my final answer. I can't cancel anything else there. I hope you see that. Okay. Any questions about that? All right, this one over here. All right, and I'll change colors here to make it real clear, I hope. When we do this fraction here, we are going to flip it and multiply once again. So I'm going to go 27a cubed b divided by 4. Now I'm going to multiply by the reciprocal of this. I'm just going to bring everything that was on the bottom here up to the top. Divide that by 9, and now I can start canceling. 4 goes into 16 4 times. 9 goes into 27 3 times. So my coefficients look like it's going to be 12, right? 3 on top times 4 on top gives me 12. A cubed times a to the 1st is going to give me a to the 4th. B to the 1st times b squared is going to give me with b third. And the only thing on the bottom is these, and these were canceled, so there's really a 1 on the bottom, but this divided by 1 is going to be my final answer. I hope you see that's true. Okay. Moving on. What you guys should notice here, and you can fill in this Venn diagram on your sheets now that we've done a couple of examples here. So fill this in your sheets there. Okay, but when you multiply fractions, work straight across the fraction. The coefficients multiply like we did. I could have gone 6/4 if we wanted to. Okay, which would have reduced to 3/2, which is what I had in my final answer, remember. And when I multiply and with the variables, I multiply the exponents, add and subtract. Remember, I did x squared times x to the 3rd is x to the 2 plus 3, or x to the 5th. Y was by itself, y to the 1st, and then 4y squared was on the bottom. Now I would subtract them again. 1 minus 2 is a -1, so a y stays on the bottom. That'd be y to the -1, right? X to the 5th on top stays there, and this was my final answer from the previous slide, as you can see here. Okay, so work straight across the fraction. But you can also cancel diagonally like we did. I think when I did over there, I just did this and got straight to my 3/2 immediately. But either way, I think you know how that works. Okay. Notice we don't need common denominators like you do when you add fractions. So notice this is what both of these, multiplication and division, have in common. You don't need common denominators. All right, you can just start cross multiplying once you have flipped this fraction here. So once again, like from on the other page, I simply did this 27a cubed b divided by 4, and I multiplied by the reciprocal of this, 16ab squared divided by 9, and I started my canceling. Okay, 3 times 4 gives me my 12, and once again, a to the 4th, 3 plus 1 here, right, a to the 1st, b to the 1st times b squared gives me b to the 3rd. I add the 1 and the 2, and there we are, we're done. And that's exactly what I got earlier. Okay, so notice this Venn diagram. Take a minute here to finish that, and I'll pause for you here. And so you can take care of that. Make sure you get that Venn diagram filled in. Okay, so back to some basics here. We want to make sure we understand once again that we can start canceling here. A -4 goes into an 8, which gives me a 2 down here. 5 and a 15 gives me, oops, a 3. 5 goes into 15 3 times. Don't forget that negative sign, though, so this would be -1/6. There's a 1 up there, -1/6. Okay, I'd like you to work out example 2 on your paper with your partner, and don't forget that you must first flip this thing here and do the math there. Okay, so take a minute, work that out with your partner. Okay, about the only canceling you can do on this one is divide the 2 into the 10 and get a 5 here, and that's going to give us -13/15. There's no common factors in this, so I can't simplify it further, so that's my answer for this one here, example 2. Hope this is helping. All right, now it gets a little bit more complicated here, but the principles still apply. We're still going to work across the fraction, look for canceling, but now we have to do some factoring. The first thing we hope that you see is that this looks factorable, right? I've got 1 and 12. I can have a 2 and a 6. I could have a 3 and a 4 to get my -12, right? I'm going to have an x here and an x here. Looks like it's going to have to be minus plus for me to get a minus sign here, right? And what two numbers multiply to -12, but will add to give me a net of -4x? 1 and 12 give me 11 if 1 was negative. 3 and 4 would only give me a 1 if one of these two was negative. 2 and 6 would work though, and I need to make the negative bigger, so it's got to be -6 plus 2. -6 times +2 gives me the -12 that I need. -6x and a +2x gives me a net of -4x that I need here. Okay, hope that makes sense. Oops. So -6 and a +2. So I factor the top. Now the bottom factors as well. When you have two perfect squares, right? 4 is a perfect square of 2, and there's a negative sign in the middle. It's x minus 2, x plus 2. And this is how these problems often work out. You've got to look for patterns because they're looking for you to be able to cancel something. Okay, you can cancel it when it's the whole parentheses. I cannot cancel x squared and x squared like that. So be careful. Okay, I can cancel whole quantities when they're in parentheses like this, and my final answer is actually just this, x minus 6 over x minus 2, and I'm done. But you can cancel these, but not these. A lot of students want to do that, and you can't do that because these are part of a bigger expression. Okay, so be careful. Don't just rush and cancel x squared. It's got to be careful with that. Okay, there's your final answer. All right, moving on. All right, one more example here. I want you to take a look at example 3 in page 555 in your book, okay, and follow those numbered steps they give you in solving this problem. Okay, first on your note sheets here, notice we're asking you to go to that page in the book and actually write out those numbered steps. They're in blue font on the right side of that example. Take a minute now to do that. Okay, hope you read example 3 and wrote out those numbered steps. Notice what they say here to do. They do say to factor both numerator and denominator. So the first thing I'm going to try to do here is I'm going to try to factor these. Okay, the bottoms both look like they can't be factored. This looks like it can't be factored any further. The only thing to be factored is this top parentheses polynomial here. So it looks like that's going to be an x minus something times an x plus something. What is going to multiply to plus 3 and add to a negative 2? Well, it looks to me like it's going to be a minus 3 and a plus 1. That would multiply to give me, that won't work. Actually, that's a mistake. Yeah, I've got a typo in my problem here. I think we want to make this a minus 3, so just make this plus a minus 3. This was meant to factor nicely into this. So this whole polynomial here, if that's a minus and not a plus, this should factor into x minus 3 and x plus 1. If I'm going to get the minus 3x plus 1x, which gives me a net of minus 2, the minus 3 and the plus 1 gives me a minus 3 here. That plus should be a minus here. Either way, I am going to get this, and this is how it was meant to work out. Just had a typo there, x plus 2. And now the only thing I can cancel here is this and this. So my final answer here is going to be x times x minus 3, whatever is left on the top, divided by x plus 2 on the bottom. That's all I can do. So if I follow those steps on page 555, that's all I've got to do is divide out common factors and leave it in the simplified form. So this is meant to help you by going over that example. Notice that one example, they did have a 1 minus x, and they changed that to a minus 1 times an x minus 1. They moved the order of these two and changed the signs, right? This is a plus 1 minus x. That's a plus x minus 1. They just moved a negative 1 out front, and that makes things cancel sometimes nicely. So be aware of that little trick they did on page 555 in example 3 there. Okay, be aware of that little stunt or that little tool. All right, moving on here. You've got several more examples. I'm going to pause the recording right here and see if you need some time to work on this one. So work on example 4 with your neighbor, trying to factor and then cancel. This example 4 has a lot to do, but it's very doable and it works out kind of nicely if you factor properly. If I look at this top term here, I can pull out an x and come up with x minus 2 is how I would factor that one. The bottom of this fraction looks like it is x plus 1 quantity squared. So I can write it as x plus 1 times x plus 1, right? And then over here, this looks like it's going to be x plus 3 times x plus 1. Nice, easy one to factor. I hope you see that. And over here, I've got an x and an x in each term, so I can pull an x out of this, and what's left is x plus 3. And now I've got some real easy canceling to do. First things that are obvious are this and this, this and this, and the x can be canceled as well. So really, the factoring wasn't too bad, and I hope you see the final answer here is going to be x minus 2. This is what remains on top. What remains on the bottom is just x plus 1. It's really a fairly simple final answer for all the complexity that appeared to be here. So I'm going to stop this video now and save it. We can move on with the next video after this.